All right, ladies and gentlemen, this is your chapter 5.1 to 5.3 quiz review for your quiz tomorrow. All right, now as you notice, what you have to do whenever you graph something, you have to put it in y equals mx plus b form. That's slope-intercept. M is the slope, b is your y-intercept. So notice what I did. Here's your slope, here's your y-intercept. So what you're going to do is we're going to graph this. Now I'm going to try the best I can because I don't have a ruler with me, but at -3. So remember, this is the y-axis. It has to be on the y-axis. That's why it's called a y-intercept. So 1, 2, 3, we're going to come down here to -3 and put the y-intercept. Now we're going to put, you can find all your other points by going up 4 to the right 1. So 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. Okay. Now, we're going to try our best. Actually, we're going to do one more. 1, 2, 3, 4, and down 1. So those are the points. I'm going to try my best to make a line that'll incorporate those. So here we go. We're going to do this right here. All right. Now, the next one I'm going to do is I'm going to do a slope of -3, 1 at a point of 0, 4. So I'm going to go up 1, 2, 3, 4. So there's your point right there. Now, in the slope, since it's a negative slope, remember it has to go this way. So I'm going to go down 3, 1, 2, 3, and to the right 1. Notice it overlaps right there. So I'm going to go one more, 1, 2, 3, and down 1. And then I'm going to connect that line right there. And therefore, my solution is at 1, 1. Now this second graph I've already done for you. On the second graph we had a y-intercept of 0, 1. Notice I had to solve for y, so I had to move the 2x over. And then when I did that, they gave me y equals -2x plus 1, so a slope of -2 over 1. Let's see. I need to drag this a little bit more. Okay, and then on the last one down here, I got a slope of 1/2 and a y-intercept of -9. And therefore, your intersection is at 4, -7. All right, for questions 3 to 4, solve the system of equations by using substitution. Now, remember, you must solve for one of the equations, or solve one of the equations for either x or y. So in doing so, you just got to make sure that you follow that along. So here, what I'm going to do is I'm going to bring this one over, and I'm going to blow this one up. This is the first one. So we're going to take a look at this one right here of x plus 3y and 4x minus 2y equals -6. So let me move this out of the way. And here's what happens whenever you do this one. All right, so notice what you're going to do is this. I solve for x, so I'm getting x by itself. And I got x equals -3y plus 9. I'm going to plug it in for this x right here. So what you end up doing is this. You end up going 4 times -3y plus 9 minus 2y equals -6. I'm going to then distribute this 4, and I get -12y plus 36 minus 2y equals -6. I'm then going to combine like terms, and I get -14y. Oh, that's not a good color right there. Let's try this one. Let me erase that. And then what happens is you end up, when you connect these two right here, you get -14y plus 36 equals -6. I'm then going to I'm then going to subtract 36 from both sides. And when I do that, I get -14y equals -42. Well, then when I divide by -14, you're going to notice that y is equal to, now negative divided by negative is positive, and 14 goes into 42 3 times. So now that you've got y is equal to 3, all right, you got y is equal to 3. Now we got to go find our x. Well, I'm going to go plug that back in right here. So I get x equals -3 times 3 plus 9. And x equals -3 times 3 is -9 plus 9, and that is 0. Therefore, it's an intersection of 0, 3. Okay? Now that's the first one. So what I'm going to do is I'm going to take all of this together. push it off to the side. I'm going to bring this back. Now look, on this one, now we're going to solve this problem here. 2x plus 5y equals negative 7, and 7x plus y equals negative 8. So let me go ahead and move that out of the way. All right, let me bring this back, and let me show you what I did. Well, I took these two equations, okay? So I took these two equations, and now what I'm going to do is I've solved this one for y right here, all right? Solve this one for y. I'm going to plug it into the first problem. Now, I did just realize I did make a mistake. Notice this negative here. I didn't make a negative here. So that should be a minus 8, not plus 8. So now when I solve this, I'm going to plug in negative 7x minus 8. And then equals negative 7. So now I'm going to solve this problem. I'm going to distribute the 5. And what I end up getting is 2x minus 35x minus 40 equals negative 7. I'm going to combine like terms. I get negative 33x minus 40 equals negative 7. Oops, that's supposed to be an equal sign. All right, then I'm going to add 40 to both sides. And when I do that, you're going to see some things start to be clear. Bring down your negative 33x. And this turns out to be a positive 33. Well, lo and behold, divide both sides by negative 33, and x equals negative 1. Plug it back into this equation right here, and you get y equals negative 7 times negative 1, and then, of course, minus 8. And you get y equals positive 7 minus 8, which is actually negative 1. Therefore, you have an intersection of negative 1, negative 1. Okay, now, for questions 5 and 6, you have to solve using elimination. Make sure that they're in the form of ax plus by equals c, or at least x and y are on the same side. And then line them up. And then you get to, once you do that, then you can decide whether whether you want to eliminate the x or the y. So it's your choice. Now remember, you're going to add if they're opposite signs, and you're going to subtract if the signs are the same. All right, so let's take a look at this first problem. Now, I want you to notice something. The x's and the y's, the leading coefficients in front of those variables, are not the same. And they're all positive. So now what I want to do is I want to do something to where one of them's negative, one of them's positive, because I prefer to add as opposed to subtracting. So here's the deal. What you can do is this. One of the things you can decide is that I know that I want to eliminate the x's. So this is what I'm going to do. I know both 4 and 5 both go into 20. So what you can do is I can simply do this. I can multiply this by 5, and I'm going to multiply this by negative 4. Now, I want you to notice what happens when you do that. Okay? When I do that, you got to distribute to everything. So what ends up happening is you end up getting 20x plus 15y equals negative 5. And then down at the bottom, when you distribute, you end up getting negative 20x minus 16y and negative 4. Now notice that's the reason why I made this a negative 4, because now if you notice the 20s are both opposite and they're the same number. So now my choice is to add because they're the same number but different signs. So when I add straight down, the x's cancel out. 15 plus a negative 16y is a negative y. And negative 5 plus negative 4 is negative 9. Now remember, there's an understood 1 right here. So I'm going to divide by negative 1. And y is going to be positive 9. Now, I don't care which equation you choose. Just choose one of them. I'm going to choose the top one. So 4x plus 3. I'm going to leave the parenthesis open for y because that's your 9 that you just solved right there. Okay. Equals negative 1. 3 times 9 is 27. So 4x plus 27 equals negative 1. I'm going to then subtract 27 on both sides. and I get 4 times something is equal to negative 28. Now, I'm going to divide both sides by 4, and I know that x is equal to negative 7, and therefore my solution is negative 7, positive 9. Okay, that first one is a little bit more in depth. This one's a little bit easier. Notice that your x's and y's, again, they're not the same number, so I can't just add straight down or subtract straight down. But what I can do is this. I know the x's have a 1 right here. And I know that 7 and 5 are both opposite signs. Well, what I'm going to do is I'm going to multiply this top one by 2. So then I end up getting 2x plus 10y equals 40. The bottom one stays the same, so 2x minus 7y equals negative 45. Now, I know we've discussed this before, but you got to be careful. Since the x's are the same, you're going to subtract. But remember, you got to subtract the whole line. So you have to be careful on that. 2x minus 2x cancels out. 10 minus a negative 7 is actually 17y. And 40 minus a negative 45 actually makes that plus a 45. So that is actually 85. Now, you can either do this in your head. I'm not sure if I'll let you use the calculators or not. But when you divide by 17, y is equal to, well, think about this. If you multiply this by 17 by 5, 5 times 7 is 35, carry the 3, you actually get 85. So I know that my y value is 5. I'm going to go back to the original equation of x plus 5y equals 20. I'm going to plug in 5 for y right there. So this goes right there. I get x plus 5 times 5 equals 20. So x plus 25 equals 20. And then when I subtract 20 on both sides, when I subtract 25 on both sides, let me erase this. When I subtract 25 on both sides, I end up getting x equals negative 5, and therefore my solution is negative 5, 5. On problems 7 through 9, you need to define the variables and set up a system of equations. Solve by either substitution or elimination. Now use letters that go with the word, or you can still use x and y, but tell me what each one represents. Okay, on this one, the sum of two numbers is 36. So I said let x equal the first number, let y equal the second number. And if you notice, twice the first number minus the second is 6. So now that I've set those up, now we can solve these. So I'm going to move this out of the way. Now notice they're both real simple. So I'm going to actually stack these. So watch. If I have x plus y equals 36, 2x minus y equals 6, notice that the y's are opposites. So my initial reaction is I'm going to add straight down. X plus 2x is 3x. The y's cancel. 36 plus 6 is 42. Divide by 3. And x is equal to 14. You know what? I'm going to plug it back into this one. So 14 plus something is equal to 36. Minus 14. And I end up getting y is equal to 22. Therefore, my two numbers are 14 and 22. Okay, so this one's a little different. Since O looks like 0, I'm going to choose a different letter for orange. So in this case, I'm going to let R equal oranges. I'm going to let A equals apples. Now, so what I'm going to do is, notice in this particular one, I got 12R plus 7A, so 12 oranges plus 7 apples is 536, and 8 oranges plus 5 apples are 368. So I have a choice, elimination or substitution. In this case, I think elimination is going to be best, because if I have to solve for A or R, it's going to give me fractions, and plus I have decimals to work with. So what I'm going to do is I'm going to take this, and I'm going to figure out some number that I want to eliminate. Well, I want to eliminate the A's, the apples. So I'm going to multiply the top one by let's see, we can either multiply by 5 or 7, and in this case, I want to multiply by -5. That means this other one, I want to multiply by 7. The reason being, I want to make this a negative apple, and then the bottom one a positive apple. So when I do this, this is what I end up getting. I end up getting, this right here is a -60 oranges, plus a -35 apples, equals -26.8. On the bottom here, 7 times 8 is 56 oranges, plus 35 apples, equals 25.76. Now, if you notice, I can now add this bottom one because the apples are going to cancel out. And -60 oranges plus 56 is a -4R, equals, now when I add these two right here, I end up getting a -1.04. So notice all those big numbers are now gone. If I divide by -4, I get R is equal to 0.26. What that means is the oranges cost 26 cents. Well, that kind of makes sense. So now what I'm going to do is I'm going to take this, move it over to the side. I'm now going to take my oranges, I'm going to plug it back in. So you know what? I want to plug it back into the top one. So 12 times 0.26 plus 7A, so 7 times the apples, equals $5.36. Well, 12 times 26 cents is $3.12 plus 7A equals $5.36. Well, I'm going to subtract $3.12 from both sides. And what I end up getting is 7 times your A is equal to 2.24. Divide by 7, and A turns out to be 32 cents. So that means oranges cost 26 cents and apples cost 32 cents. On this particular problem, number 9, I'm going to let E equal envelopes and S equal stamps. Now this one's really easy. If you notice, 15S is equal to $2.25. So I'm going to divide both sides by 15, and I end up getting each stamp cost 15 cents. Well, now I've already got my this variable, so let's plug it in right here. So 10 times each envelope plus 13 times 15 cents is going to equal $14.45. So now it's just a matter of correct mathematics. So 10E plus 13 times 15 happens to be $1.95 equals $14.45. So I'm going to subtract $1.95 from both sides, and I end up getting 10 envelopes are going to cost me $12.50. Well, when I divide by 10, I see that envelopes are going to cost me $1.25. So now, stamps are going to cost 15 cents. The envelopes are going to cost $1.25. On this one, I think this is one of the easiest ones. Remember, when you are checking to see if a point is a solution, the only thing you have to do is plug it in. So taking this point, I'm going to plug in -3 for x, 8 for y. -3 for x, 8 for y. So -3 minus 16 equals -19. -3 minus 16 is -19. And you know what? It works for this equation. This is -15 plus 16 equals 1. -15 plus 16 is 1. Therefore, that also checks out. And because it satisfies both equations, it is a solution. Okay, the last problem you had to solve by all 3 methods. All right, I took y equals, or I solved this one for y at 0, -2. And I have a slope of -3, 1. So down 3 to the right 1. Or up 3 to the left 1. And notice it's going to be something like this. Okay? Then The other one is at 0, 7. So up here, so 1, 2, 3, 4, 5, 6, 7. So about right there, I believe. And then it has a slope of 3, 2. So up 3, down 2, or down 3, left 2. So right there. And notice that's where it's going to intersect. So that intersecting point is at -2, 4. Okay? Let me move that because it's going to interfere in my way. All right, so -2, 4. That's my solution. Now, I'm going to move that out of the way because that was my graphing. So let me discard that. I should get the same thing for substitution. Well, if you notice, here's my substitution. So in substitution, I'm going to take this and I'm going to plug it in for y. So I get 2 times -3x minus 2 minus 3x equals 14. When I distribute, I get -6x minus 4 minus 3x equals 14. Then, combine like terms, I get -9x minus 4 equals 14. Add the 4, and notice that's going to be 18. So -9x equals 18. Divide by -9, and x equals -2. All right, so now I'm going to plug it back into this equation. So y is equal to -3 times your -2, that's my substitution, minus 2. So y equals, that's going to be a positive 6 minus 2, and that is 4. So -2, 4, and that's the point. That's the same as I got on the graphing. Now, I'm going to move that out of the way, and now I'm going to do the elimination. So let's work on that one. So on the elimination problem, let me move this up. Now I have more room. I'm simply, notice that I've got them already set up. All right, so if you notice, this problem is already set up for me to do it. So I'm going to simply add straight down. The x's cancel and I get 3y is equal to 12. Divide by 3 and y is equal to 4. Well, you know what? Let's plug it back into here and I get 4 plus 3x equals -2. Minus 4 minus 4, and I get 3x equals -6. Well, you have to divide by 3 and x equals -2. And if you've noticed, I got the same answer for all three. Good luck on your test.